Okay, for this video we're going to take a look at some common functions that appear in secondary mathematics and find the domain and range of each, and the ones that are bijections will find the inverse function. First off, f sub 1 of x is equal to x squared. The domain for this would be all real numbers. Now the range, there's a few ways of writing the range. The numbers that come out of this, x squared, have to be either positive or equal to 0. So I could write the range as r plus union 0. So positive real numbers or 0. Another way of writing the answer would be like this: y, set of all y such that y is greater than or equal to 0. And set of all real numbers y such that y is greater than or equal to 0. Another way of doing this, and you might have seen this in other classes, would be with the interval notation that looks like this, where we have closed bracket 0 and then infinity with the open parentheses to emphasize that 0 is included here, and I go up through infinity. So all numbers greater than or equal to 0. So that would be the range. Okay, now, is this invertible? This is not invertible. This is not a bijection. The reason it is not a bijection is that the function is not 1-to-1. Negative 1 squared is equal to 1 squared. So if I input negative 1 and input 1, I get the same results. So this is not a bijection, and so using this domain and range, you don't have an inverse. Now it is possible to find the inverse if I restrict the domain, because obviously you know what a square root function is. But the way that it's set up now, if I permit any number to be in the domain, then this function does not have an inverse. Okay, our next example is x cubed. The domain of this function, the numbers that go in are all real numbers, and the range are also all real numbers. Okay, now this one is a bijection. The reason it's a bijection, it's 1-to-1 and onto. So if, let's go ahead and establish this. Suppose f2 of x1 is equal to f2 of x2. So x1 cubed is equal to x2 cubed. Okay, then I can take the cube root of both sides. We can write it like this: x1 cubed minus x2 cubed equals 0. That factors x1 minus x2. This factors x1 squared plus x1 x2 plus x2 squared equals 0. And so either x1 is equal to x2, or this other mess happens. And it turns out this is equal to 0 exactly when x1 is equal to x2 in the first place. So we can establish, and so we'll just establish that this is in fact a 1-to-1 function. If the function is the same, if f sub 2 x1 is equal to f sub 2 x2, then x1 is equal to x2. And this part here is just the technicality. So that's 1-to-1. It's onto. How do I show that it's onto? Let y be an element in the range. Then x cubed equals y. Can I solve for x? Well, yeah, x would be equal to the cube root of y. Okay, so that's my inverse function. So this is a bijection. So this establishes 1-to-1. This establishes onto. So this function f2 is a bijection, and I basically have already written out what the inverse function is, and the inverse of this function is simply the cube root of x. Okay, so that's the function f2. The next problem, or the next function on the list, was cosine of x. So f sub 3 of x equals cosine of x. The domain is all real numbers. I can take the cosine of any angle, that's not a problem. The range. There's a few ways of writing the range. One way of writing the range is that when I take the cosine of something, that something must be between -1 and +1 someplace. So that's the range that comes out. Another way of writing it would be with interval notation of -1, 1, using closed brackets to indicate that both endpoints are included. Okay, so that's the domain, that's the range. This is not a bijection, so it is not 1-to-1. The reason is because cosine of 0 is the same thing as cosine of 2 pi. Cosine is a periodic function, and so the function at 0 is the same as the function at 2 pi, even though these two numbers are different. So this is not a 1-to-1 function. F4. That's e to the x. Okay, the domain, well, I can put any real number in, and also I can, what comes out will be a positive real number. Now this is a 1-to-1 function. If e to the x1 is equal to e to the x2, I can take the log of both sides, and that establishes that x1 is equal to x2. So this is a 1-to-1 function. Said another way, if I graph e to the x, this satisfies the horizontal line test. It's onto. If I have y is equal to e to the x, then I can solve for, if y is some real number, then I can figure out the value of y such that e to that x is equal to y. So this function f4 is a bijection, and the inverse function I basically have here is natural log of x, just changing the letter. And the domain of f4 will be all positive real numbers. So the range of f4 was all positive real numbers. That'll be the domain of f4 inverse. And the range of f4 inverse will be all real numbers. So the domain of the original function is the range of the inverse. The range of the original function is the domain of the inverse. So that's f4. All right, let's take a look at f5. So the next example, f5 of x is 1 over x. The domain of this function are all real numbers except for 0, because I can't take 1 over 0. Okay. Another way of writing this would be -infinity to 0, union 0 to infinity, where I have parentheses here to indicate that 0 is not being included. So writing it like this or writing like this, another way would be to write it like x, all values of x that are real, such that x is not equal to 0. That'd be a third way of writing the domain. The range is going to be the same thing. If I take 1 over something, I can get any number out except for 0. So I can write like this, or I can write it like this, or I can write it like this. And I'm going to deliberately change letters to y to indicate that's going to be the outputs of this function. All right, this function is 1-to-1. If 1 over x1 is equal to 1 over x2, then I can take the reciprocal of both sides. That proves that x1 is equal to x2. This function is onto. If I have a value y and I want to find the value of x such that y is equal to 1 over x, then I can solve for x, and x is equal to 1 over y. So this is an unusual function in that the inverse is actually itself. So f5 inverse of x is equal to itself, 1 over x. This 1-to-1 and onto, so this one is a bijection, and its inverse function is itself. And the domain of f5 inverse is going to be the range of the original function, and the range of the inverse will be the domain of the original function. Our last example from secondary mathematics will be the absolute value function. The domain, I can put any real number in, and the number that comes out must be either positive or it could be equal to 0. So that's one way of writing it. This also could have been written the set of all real numbers y that are greater than or equal to 0. Alternatively, it could have been written using interval notation like this. Any of these three would be acceptable a way of writing the range. This is not one-to-one, so it's not a bijection, because if I input, say, f6 of 5 or f6 of negative 5, these are equal because the absolute value of 5 is the same thing as the absolute value of negative 5. So different inputs can have the same output. So this one is not a bijection. And so that's this problem.